All right, so it's lesson 11. Lesson 11 in Calc 1, we are marching through derivatives. And so you'll notice that everything we did in our last lesson was all about polynomials. We didn't really multiply functions together. We didn't really divide functions. We stuck with things that looked mostly like polynomials. Why? Well, because products are tricky. So you think to yourself, well, if I have the derivative of x times x, well, maybe that's just the derivative of x times the derivative of x, and we know that the derivative of x is 1, and the derivative of x is 1, and that's 1. But we also know that x times x is x squared, and its derivative is 2x, and those are not the same. And so it can't be that product rule is just, well, take the derivatives and multiply them together. And in fact, that is not the case. So let's take a look at the product rule. The product rule is the thing that gives us the derivative of f of x times g of x. And there's going to be a space where we're going to write it, but I don't want to give that away. I mean, I guess you could just skip ahead in the video, I guess. And you could feel all accomplished that you skipped ahead in the video, so what the end was. Let's take a look at what we mean by the derivative of f times g. Well, that's a limit as h approaches 0 of this at x plus h minus this at x. So now I want to do something to this that's going to turn it into something that I know what to do with. And I got to tell you, the greatest mathematical minds in the whole wide world struggled with the thing that I'm about to do. I'm about to split this into two fractions. And I'm going to keep the f of x plus h, g of x plus h over here. And I'm going to keep the minus f of x, g of x over here. And what I'm going to do is I'm going to subtract something and add it back over here so that I don't change the value. And that something, because I know that it works, is f of x plus h times g of x. F of x plus h times g of x. We subtract it out, we add it in, we do not change the value of our expression. So here's the question. What have we got? Well, on this side, we have a factor of x plus h in common, so we'll just pull that right out. And then what's left is g of x plus h minus g of x over h. Over on the right side, we have g of x in both terms, and so we'll pull that out, and what's left is f of x plus h minus f of x over h. So let's examine what happens as h approaches 0. As h approaches 0, h approaches 0, this becomes f of x. As h approaches 0, this is a difference quotient. This difference quotient becomes g prime of x. As h approaches 0, this doesn't care. As h approaches 0, this is a difference quotient. And that difference quotient as h approaches 0 becomes f prime of x. So the product rule is so much fun. It's 1 prime 2 plus 2 prime 1. One function times the derivative of the other times the derivative of the one. That's how product rules work. So by example, let's differentiate. Differentiate means find the derivative of. So let's find the derivative of this product. The product rule is so much fun. It's 1 prime 2 prime 2. So the derivative of 2x is just the slope of 2x, and that's 2. And then this is a constant, so it has a 0 derivative, so that's all we need. Plus 2 prime 1. So what's prime 1? Well, this is a polynomial. So we bring the power down, decrease the power by 1, and then this has a slope. Its slope is 5, and we stop. That's fine. That's a fine way to write the answer. Unless you have to simplify because you're going to do things with it, this is an acceptable way to leave the answer. If f of 2 is 5, f prime of 2 is negative 2, g of 2 is 3, and g prime of 2 is 4, find the derivative of f times g at 2. Well, this is also fairly straightforward. We're looking for the derivative of f times g. That's f g prime plus g f prime, and that's 5 times 4 plus negative 2 times 3, and that's 14. Product rule questions go like that. Product rule isn't all there is. What do we do with quotients? Well, with quotients, I'm going to leave the proof out. It is similar to the product rule. We figure it out in a similar way, so I'm going to leave this proof out. The derivative of f over g is g times f prime minus f times g prime over g squared. It's the bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom squared. This is calc, this is calc, this is calc. So just by example, let's see, if f of x is x minus 4 over x squared plus 4, find f prime of x. So that's taking a derivative. It's the derivative of a quotient, and the derivative of a quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom squared. This is calc, this is calc, this is calc. So then what's the derivative of x minus 4? Well, that's a number. It has 0 derivative. That's a line. It has slope of 1. What's the derivative of the denominator for here? Well, the derivative of x squared is 2x, and the derivative of 4 is 0. And then we leave it like this, and we don't try to simplify, and we just let that go. If g of x is x plus 2 times x squared minus 2x plus 3 over x cubed plus 2, find g prime of x. Well, that's doable. This is a quotient, and since it's a quotient, the quotient rule applies. It's the bottom times the derivative of the top. Now, the top, we're just going to hang on for a moment. Minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom squared. This is calc, this is calc, this is calc. Well, I'll just stall. Derivative of denominator to go here. Well, this is a power rule situation. 3 comes down in front. This is a constant. Constant has 0 derivative, so that's over there. Derivative of numerator. The derivative of numerator, that's a product. So we pause the quotient rule song to sing the product rule song. The product rule is so much fun. It's 1 prime 2 plus 2 prime 1. Derivative of the second, go in here. That's power rule. That's a line, 0 derivative. And then this is a line. The 2 has 0 derivative. And then we leave it, and we don't try to simplify, and we stop, and we put just a box around it. We're done. Speaking of being done, our video is almost done. I have one more thing that I should talk about. What about 1 over x to the n? We talked about how to take the derivative of x to the n. How do we take the derivative of 1 over x to the n? Well, the derivative of 1 over x to the n, that's a quotient. So it's bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom square. This is calc, this is calc, this is calc. Well, this is 0. And this is negative n x to the n minus 1. And we know that when you raise a power to a power, that doubles the, well, I'm sorry, that multiplies these exponents together. And so this whole thing, by rules of algebra that you learned in the 9th grade, subtract the exponents. If you subtract the exponents, that's negative n minus, oh golly gee. So sorry. X to the negative n minus 1. Well, wait a minute. This is x to the negative n. X to the negative n. X to the negative n. This is negative n x to the negative n minus 1. So what happened? We took this power, pulled it down in front, and then decreased the power by 1. But that's just what the power rule does. And so we learn from this that the power rule works for negative powers also. It doesn't matter if the exponent is positive or negative, the power rule still applies. When you see something that looks like this, to take its derivative, you bring the power down in front and decrease the power by 1. Doesn't matter if this power is 12 or negative 12, the power comes down, decrease the power by 1. If you are looking for practice, and I believe that you are, you're looking in section 3.3 for 113 and 117 and 123 and 127 and 129 and 131 and 141. And this reminder, at the back of the book, in the PDF, all the odd answers are, so it's worth taking a look. We'll see you in class.